on making your own air conditioner. There will be a moderated Q&A at the end, so save your questions, and the microphone is dead center. Okay, thank you.
You won't have to make the whole air conditioner yourself. This is a very big room. People in the back, I'm going to have to pretend you're not here so I don't pass out. Sorry. So I know you're all here because it's managed to be a balmy few degrees above freezing here in Montreal, and you just wanted to talk about air conditioning. But if you can think back to what it's like over the summer, I live in New York. It gets pretty muggy, and I would come home to my room, and I would just make a beeline for the air conditioner. And I would kind of stand there trying not to touch anything, and finally the room would cool down. And I would go to bed, and then I would wake up in the middle of the night freezing. And I started thinking to myself, man, wouldn't it be great if there was some way to have your air conditioner sort of control the temperature itself, and maybe you could even turn it on before you got home? And then I thought, someone has already made that. That's already a thing. But I decided to make it myself. So today I'm going to talk to you about how I made that happen. And I just want to get a sense, how many of you in the room have done a project with Raspberry Pi before? Okay, cool. And how many of you have written any kind of web app before? Awesome. So for me, this was kind of a hello world project. I hadn't done either of those things before, and that's kind of the way I'm going to approach it, but I hope it also gives you some motivation or inspiration for cool smart home projects of your own. So the goal, as I said, is to be able to turn your air conditioner on and off when you're not at home, but also to be able to turn it into a thermostat so it can control the temperature for you. But to be a little bit more specific, it's going to be something a little like this. You'll have a Raspberry Pi that controls your air conditioner and the temperature, and it's going to be checking in, saying, here's what's going on, what do I do? And at some time, you'll tell it, turn on. And when it checks in next, it'll get that instruction, and it'll turn on. And in a slightly more complicated way, you'll want to set a particular temperature. So again, the Raspberry Pi will just be checking in, and eventually you'll tell it, be at 72 degrees or something like that. And when the air conditioner next checks in, your server will figure out what it should do, and it will respond accordingly. So there's a couple components. First, I'll talk about how to set up all the hardware to make these things possible, and then I'll talk about writing a simple web app in Flask so that we'll be able to communicate with the air conditioner. To get started, you're going to need some stuff. So assuming you already have an air conditioner, I estimate the cost for all of these things when I did the project was somewhere between 80 and 100 bucks. But the great thing is that all of these parts are reusable. So when it's winter and you don't need your air conditioner, you can just take it apart and use everything again. You'll also need this really awesome resource. I highly recommend adafruit.com. Pretty much everything I bought and everything I used, all the tutorials I used came from Adafruit, so I highly recommend it. You'll need an air conditioner. To do the project the way I did, it needs to be a window unit air conditioner that plugs into AC power, draws less than 15 amps, and as always, there's a small chance that something could go wrong, so just be mindful of that. But my air conditioner is still intact. You'll need a Raspberry Pi. You'll need some other components for it. And don't worry if I'm going a little quickly through this. I will make the slides available later, and I also wrote a blog post about getting started with Raspberry Pi for the first time. If you haven't done that, there are some things that were a bit tricky for me, like getting set up with Wi-Fi. So yeah, check it out. You'll need a little bit more stuff, a power switch or relay, which I'll talk about in a minute, a temperature sensor, some wires, some prototype PCB paper, some tools, and we'll see what we do with those later. And for testing or debugging, I highly recommend you have a breadboard and some LEDs. And that's just so that you can do a solderless circuit, plug and play, and you won't have to have any hot metal. And honestly, you could do the whole project just with the breadboard. It holds things in pretty tightly, but there's a small chance that things could fall out. And a multimeter is nice to have for debugging, but it's definitely not necessary. So, now that you have all the stuff, I'm going to talk about how to put it all together in order to lay the groundwork for this application that we're going to build. So there's two things that the Raspberry Pi is going to need to be able to do. It needs to be able to turn your air conditioner on and off, and it needs to be able to measure the temperature in your room. So to do that, there's just two simple circuits. First, we'll need to make the Raspberry Pi able to control the air conditioner. So to do that, we'll use a relay, which is just an electrically controlled switch. So it's as if you took your air conditioner's power cord and just cut it in the middle, and between the part that plugs into the wall and the part that plugs into your air conditioner, you put like a light switch. But instead of controlling it with your hand, we're just going to control it with a little bit of power coming from one of the Raspberry Pi's output pins. So when power flows from that pin, the switch will close, and power can flow from the wall to your air conditioner. And when we set that output pin low and no power comes from it, then the switch will open, and the air conditioner will turn off. And the air conditioner itself will always be in the on position. So on mine, that's just the dial is turned to on all the time. And so the first thing you should do is consult a pinout map of your Raspberry Pi. And I like to look up one that has a picture of the Raspberry Pi in the background so you can make sure you're oriented. And find a pin labeled GPIO for general purpose input-output. And I happened to use a temperature sensor that had some code that hard-coded using GPIO 4, so I avoided that one. So let's pick GPIO 17. So connect brightly colored wire to that one, and then a dark colored wire, just so you know which one has power flowing from it, and connect that to ground. And then you'll take your power switch, and the red wire will go into the plus in spot, and the black wire will go into minus in, and you can ignore the third spot labeled ground because you're already grounded. And it has some screwdrivers in the top. It has some screws in the top, so you can put the wire in and then screw it back down so it doesn't just fall out, and you'll be able to control the air conditioner reliably. Now, while you're testing your application, once we've written it, there's really no reason to be connected to the power switch or your air conditioner at all. It's kind of hard to lug around with you. You might want to test it somewhere else. And because all we're doing is controlling whether power is flowing from that Raspberry Pi output pin, you can just connect it to an LED in your breadboard, and if you can turn that light on, you can turn your air conditioner on. So now that we can control the air conditioner from the Raspberry Pi, we also need to be able to measure temperature in the room. So to do that, I used a digital temperature sensor. And I won't go into too much detail about how the circuit is wired up. Again, I bought it from Adafruit. They had a nice tutorial. They had some code samples. It was really easy. All you need to know is that the yellow wire is the data wire, and that will also be connected to a GPIO pin. But this time, we'll be reading from it. We'll be collecting data, and that will be converted into Fahrenheit or Celsius degrees, whatever you prefer. And sometimes it's a little bit easier to see the diagram this way. And then, once you're all set with that, you can solder it together on some prototype PCB paper, but again, you definitely don't have to. You can just leave it in the breadboard. So now we have all the connections in place that will make it possible for the air conditioner to control, for the Raspberry Pi to control your air conditioner and to sense temperature in the room. So we have the air conditioner, the Raspberry Pi, the digital temperature sensor, and they're all connected. Now that that is ready, I'm going to talk a bit about how to write a simple web app in Flask, because it's great that we have all this hardware connected, but if we can't communicate with it in any way, it's kind of useless. So we're going to need something hosted somewhere on the internet where you can go to a page in your browser and you can send some instructions that you want your air conditioner to follow. And the Raspberry Pi will also need to be able to reach this place wherever it is and get some information that you've left for it and tell you what the temperature is in your room and other things like that. And we'll need to be able to store that information in between. So the Raspberry Pi will check in and say, it's 70 degrees in your room and the air conditioner is on. We'll need to store that so that when the user goes to the page in their browser, they can see that information, and they can also send some information. We'll need to store, oh, the user said they want the air conditioner to be on, so that when the Raspberry Pi checks in, it'll get that information back. So to do this, I used Flask, which is a web micro framework for Python. It's super lightweight, really easy to set up. You can write a one-page application, so I highly recommend it. There's some really great resources out there on the internet, and in particular, the Flask Mega tutorial, it's definitely more information than you even need to do this project, but it's a super interesting read. So you just set up root directory with your app.py file in it, and then 2 subdirectories, assets and templates, assets for any CSS or JS that you might want to use, and templates for HTML. And this is what a really simple Hello World application looks like in Flask. And you may recognize the decorator syntax. And if you're familiar with decorators in Python, that's awesome. If you're not that familiar with them, that's also totally fine. What you need to know is this says, add the following rule. When we get a request from a URL like / in this case, or www.mysite.com / then run the following function, run the hello function. And that function is going to go find the template called index.html. It's going to pass in whatever variables we've given it. And Flask comes with a templating engine called Jinja. So it'll pop that data into the template and then display, oh, I guess that's a little off the screen. Oh, you still can't see it. Well, anyway, it'll display something that says, hello, world, and hello, Miriam. And if you run it in debug mode, you'll get a nice stack trace on the page, which is convenient. So for that hello world application, we only had one endpoint, the hello route. For this application, we'll actually need 3 endpoints. So first, we have the home page. And for that, we'll just get some information that the server has stored about what's going on in the room and display that the form that you would use to send some information to your server about what you want the air conditioner to do. And then we'll need to write the endpoint to actually do that, to allow you to submit that form with your instructions. And we'll need a route for the Raspberry Pi to check in, give the server information about what's going on in the room, and get instructions back. So the first endpoint for the home page looks very much like the Hello World example. And you can see you can add as many root decorators as you want. So in this case, both / and index will give you the home page. And the only difference is we'll need to get data that has been stored by the Raspberry Pi to display. And you can do that really however you want. When I did it, I used the Python SQLite 3 library. Mostly, I wanted to keep some information about what the temperature was in my room and how much I was using my air conditioner. But if you don't want to do that, and hopefully no one will yell at me, but you can probably just store it in a global variable and everything will be okay. And it'll display a beautiful page, something like that. And you'll see the most up-to-date information you have about your room and your air conditioner and the form that you would use to send some information. Now, as you can see, the user has sort of 3 possible things they might want to say to their air conditioner. You might want to say, just turn on and be on. Or you might want to say, just turn off and be off. Or you might want to say, keep my room at 72 degrees. But the thing is, the Raspberry Pi really only understands 2 states. It can set the switch pin high and turn the air conditioner on, or it can set it low and turn the air conditioner off. So we need a way to translate between what the user wants the air conditioner to be doing and what the Raspberry Pi can actually carry out. So there'll be sort of a middle layer. We'll go from the 3 states the user knows, and then write a function to translate that into the states the Raspberry Pi understands. And on and off just map nicely to on and off. But when you specify a temperature, you'll need to just check what is the temperature in the room right now, what temperature did the user just say they wanted, and then respond to the Raspberry Pi with either 1 or 0, on or off, accordingly. So now we'll write that endpoint for the user, and we'll get the data that they sent in their post request, find the most recently stored temperature, translate that into the desired state, and again, store that somewhere. And finally, we'll write the root for the Raspberry Pi, and we'll get the data from the Raspberry Pi's post request, store that temperature and the air conditioner state somewhere, and then we'll respond to that request with whatever the most recently stored desired state from the user is. So now that that application is up and running, the last piece of the puzzle is, it's all well and good, we could go to this website, we could send some information, say we want the air conditioner to be on, but if the Raspberry Pi isn't checking in with the server, it's never going to get that information, because the only way we're sending it instructions is we're responding to the Raspberry Pi's post request. So on the Raspberry Pi, we'll need to make requests, set the switch pin high or low accordingly, and do that over and over and over again. So in order to make requests, I use the request library. It's great, it's super easy. You put in the URL / the root, the endpoint you just wrote, send the data about the room and the air conditioner, and then the response will be stored in this variable r. And then we need to be able to set the switch pin. And in order to do that, you need another Python library called rpi.gpio. And there's a tiny bit of setup. You just tell it which pin on the Raspberry Pi you're using as your switch pin. You'll tell it that it's an output pin, and you'll set it false to start. And you can just write a simple function to check whether that pin is high or low. And finally, we'll put it all together and control the air conditioner magically. And it'll just look like this. You make the request, get the response, and if it comes back with 1, set the switch pin high and turn the air conditioner on. If it comes back with 0, then we'll set the switch pin low and turn the air conditioner off. Now, that's great if we do that once, maybe get 1 instruction, but we'll need to put that in a loop and do this over and over and over again. And I think mine was going like every second or something like that. And that's all well and good, and it works for a while, but what happens, what happens if the server doesn't respond? And that's going to happen at some point. You're just making requests over and over and over again. And right now, if we just have a while loop, it's just going to break, exit, and we'll lose contact with the Raspberry Pi entirely. And that's kind of was my worst case scenario, that I would be away from home, turn the air conditioner on for some reason, and then everything would crash, and I wouldn't be able to turn it off, and it would just be sitting there wasting power. So just to make that a bit more resilient, we can put that in a try-catch block, try to make the request. If it succeeds, just keep going in the loop, wait a second, try again, wait a second, do it again. But if it fails, then we'll check how long has it been since the last time we got a successful request. And if it's been under 5 minutes, just keep going, just keep trying. If it's been over 5 minutes, turn the air conditioner off, and then just keep trying, because hopefully the server will come back at some point, or you'll fix it, you'll go in and see what went wrong. And that way, you don't have to SSH back into your Raspberry Pi and start the program running again. It just hopefully won't crash, and we'll just keep waiting. And that way, you can enjoy a perfectly temperature-controlled room all summer. And I just have some final notes, or really a final note, which is about security. And as we all know, the internet isn't the safest place. And beyond just someone malicious trying to execute code on your server or something complicated, it would be pretty bad if just like any old person could find your website hosted wherever on Heroku or something and turn your air conditioner on. So at minimum, just like you can use route decorators in Flask to map URLs to functions, you can also use other decorators. So you could write a login required function that checks some credentials of some sort, and use a decorator, wrap that around your view function, and then if the credentials aren't there, don't execute the function. And you should also probably check that the input that you're getting is what you expect. So if it's the form in the browser, you expect to be getting a number, and you expect it to be a temperature in some reasonable range. And if it's the Raspberry Pi, you expect to be getting the temperature in the room and just a Boolean on or off. So you should probably make sure of that. And now I will show you a quick demo of my air conditioner in action. It is not the best video, and it will only work if you're all very quiet. I'm just going to do a quick demonstration here of how I can turn my air conditioner on from my browser. So I'm going to go over to this page, and let me just refresh. Okay, so my air conditioner is off, if you can see that. It is, in fact, off. You can't hear anything, and you won't see any little red light on the power switch. And I'm going to tell it turn on, so I just click that radio button, hit submit here, waiting, waiting, give it a second. Did you hear that? You can see that red light. And I'm going to tell it to turn off. One take. And there you go. One take. Thank you so much, everybody. And I just wanted to say a quick thanks to the Recur Center / Hacker School, because I really could not have done this project without everyone there. So thanks.
All right. Thank you, Miriam. If anybody has any questions, then they can come up to this microphone and ask them. Thank you.
Hi, thanks for the talk. I'm curious if this project has made you more excited or less excited about sort of the promised future of the Internet of Things.
That's a good question. So it made me really excited about doing more Internet of Things projects myself, because they're really fun, but I think it kind of demystified, to some extent, like how cool these devices are, because it's really not very hard to put together yourself. So yeah, and I also think it's going to be a long time before my smart air conditioner can do my laundry, so, you know.
Thanks for the talk. I actually did smart thermostats for a while before my company folded, and I was just kind of curious, have you looked into getting into maybe humidity sensors and seeing if you can get more thermal comfort levels? So if you got really high humidity, you don't want it to get really cold,
right,
even if it's set to the same temperature as normal.
Yeah, that's a really great idea. I haven't tried to do that, but I know there are all sorts of like fun sensors that you can get for the Raspberry Pi, so I'm building up a collection of new toys.
Cool, yeah. I look forward to checking that one out.
Hi, Miriam. Did you decide to check in on the server like once every second with any like data, or did you just decide that arbitrarily?
Sorry, I didn't hear the very end of the question.
Or did you just decide how often to check the server arbitrarily?
Yeah, I just decided arbitrarily. Since I designed this just with myself and my Raspberry Pi in mind, I wasn't thinking very much about like blowing up the server with requests, because it just was only me using it. So I figured once a second would definitely be frequent enough and would be fine. So it was pretty arbitrary, yeah.
Thanks.
Do you think you could open up the AC and figure out things like fan speed, or, I mean, more than just on and off? Did you learn enough to do more than that?
At the time that I was doing this project, I definitely would have needed some help to do that, and I probably still would. I think it's possible, but I sort of weighed the chances that I would break something or set my room on fire against like how cool that would be. So, but you know, maybe one day.
Hey, thanks for the talk. So I think the only thing worse than waking up without my AC on would be having to get on my computer and reboot a server because my AC isn't on. Did you think about any ways that, like, I totally understand the idea to turn the AC off if it's not responding because you don't want to just leave the thing on. Are there any other ways you could, like, get around that and, I don't know, make it fail-proof but also hit a targeted temperature or something like that?
Yeah, I mean, so I might, just as a very simple solution to that, kind of, if it's in the like on state, then turn it off because it would never turn itself off. But if it's in temperature control state, it could probably survive on its own for a while till I get home. But in order to do that, I would have to also make sure to store like what the Raspberry Pi thinks the state is, and I kind of left that logic on the server. So, you know, it would definitely be something to think about. Yeah.
A little bit of shameless advertising. I want to say if anybody's interested in environmental monitoring, I've got this very large and extensive open source project written in Perl that needs to be ported to Python. So if anybody's interested, I'd be delighted to get some help, and it would relate very nicely to what you're doing. And
All right.
Great talk, thank you.
All right, thanks.
Hey, can you do the same thing with a space heater, or is it electrically too dangerous or something?
Space heaters are pretty dangerous. I would not do it. But that's me. If you like to live on the edge, I told you not to. Anybody else? All right, thanks so much, you guys.